Hey everyone, welcome back. We're now in week 6 of machine learning, about halfway through. Last week we looked at the big problem of overfitting, which came with the analysis of bias variance. This week we need to pursue how to cure the problem of overfitting, and we're going to be taking at two distinct techniques which are very complementary to each other. One is validation, and the other one is regularization. But let's first recap what we did last week. Last week we talked about different sources of cost in terms of our mean squared error analysis. We looked at three components. We first looked at bias. Bias is the cost associated with using the particular hypothesis set to approximate f on any data set. Here we learned the idea of an average hypothesis, which we're going to use to say is similar to the best hypothesis that could be created by a particular hypothesis set H. We saw that bias measures the approximation error of f over any data set in the limit, similar to what we do in statistics, where we're given a function and we need to approximate it. But of course, that's not the whole story in machine learning. In machine learning, we're very interested in the variance, because this is specific to the data set that's given. By using a variance analysis, we can understand how much cost is due to the variation in the data set that might be drawn from the input probability distribution. And we measure that based on the distance between the hypothesis set created on a specific data set D and the average hypothesis, which we understood from the analysis of bias. We'll call that source 2. The final source was what we normally mean by noise, stochastic noise, which is uncontrollable and due to measurement error. When we measure another value of the output on a particular input, we might get different results. Hence, this is uncontrollable noise, stochastic, and of high frequency. We saw that in all three cases, we have to add these together to get the final error amount. And this means often we need to match and so there will be many cases where we have to match what type of model we want to engineer to the data resources available, meaning the quality and quantity, and not to what we perceive as the actual target complexity. Let's continue with looking at what we're going to learn this week. The learning outcomes for this week are to first understand regularization as a means of restraining the model. We're going to learn how to choose appropriate doses of regularization for a model, and this will be done in our post-lecture work. We're going to also understand and be able to execute the idea of validation. We'll do the understanding today in the pre-lecture and the execution of it in the in-class session. Validation is a reality check by peeking at the bottom line, by dividing our data set, the training data set, into two parts. One to actually train the classifier, and another one to check the performance of the training. We're going to look at how the different forms of extending validation encompass additional estimation. And we're going to understand how validation and regularization complement each other in their roles of affecting learning.